Okay, this is Math 2, Unit 7. This is a review worksheet. And so we're going to go through this together today to just see if you're ready for your upcoming unit test. So let's find the value of x and show all the work and leave answers in simplified radical form. Okay, so for our first one here, we have a right triangle. So what we can do so far is we know that x squared plus 8 squared equals 12 squared. And so x squared plus 64 equals 144. We subtract 64 from both sides, so that x squared, in our case here, is going to equal 144 minus 64. That's going to equal 80. Okay, we do the square root of both sides, so that x equals the square root of 80. I'm going to pull this up to here for now. So let's do the square root of 80 and see if we can break that apart. 80 becomes 8 times 10. 8 becomes 4 times 2, 10 becomes 2 times 5, and 4 becomes 2 times 2 as I break that apart. Okay, so I'm going to look for some things that go together. I have a pair of 2's here, I have a pair of 2's here, and I have a 5 by itself. So I can take 1 2 and put it on the outside, another 2, put it on the outside, and keep the 5 underneath the radical. So that simply becomes 4 root 5. For my missing x value for number 1. Okay, number 2, similar idea. Here I have 15 squared plus x squared equals 17 squared, like so. Okay, and so then that becomes 15, this becomes x squared equals 17 squared minus 15 squared, right? So we can take the square root of, well, we do this. We do 17 times 17, and we have 289 minus 15 squared, which is 225. 225 equals x squared. So 289 minus 225 is equal to 64. 64. So x squared equals 64. Take the square root of both sides, and x is equal to the square root of 64, which is going to be, in our case here, 8. All right. Number 3, the lengths of two legs of a hypotenuse right triangle, the lengths of two legs of a right triangle are 2 root 3 and 5. Okay, so we have a right triangle. Okay, let's call it like this here. We want to find the length of the hypotenuse, which is x, and we have a 5 and we have a 2 root 3. Just making up which one goes where. Okay, so to find the length of x, that's going to be 5 squared plus 2 root 3 squared equals x squared. 5 squared is 25. 2 root 3 becomes the same as, write this out here, 2 root 3 times 2 root 3, like so, which equals x squared. So root 3 times root 3 gives you just a 3, right? So I'm left with a 3 there. 2 times 2 is 4. So the 4 times the 3 gives you a 12. And that's going to be added to 25, which gives you a total of 37 equals x squared. To get the x by itself, we take the square root of both sides. And so x equals the square root of 37, which I can't break down any further, so I leave it like that. Number 4, decide whether it is a right triangle. If it's a right triangle, then the small sides should square together to and add square and sum together to equal the square and sum of that one right there. Okay? That's what it should work out to be. So let's see if that's the case. Is 8 squared plus 15 squared equal to 17 squared? That's the question. So 8 squared is 64. We know that one. 15 squared is 225. Okay, so 225 plus 64 is 289. 289. And what does that equal? Well, what's 17 times 17? 17 times 17 is 289 according to our calculator. So that's 289, that works, so we would say yes, it's a triangle, all good to go. Number 5, same idea. 4 squared plus 10 squared equals 12 squared. Again, take the two smaller lengths and add them together to make the longer length. So 4 squared is 16, plus 10 squared is 100, and 12 squared is 144. 100 plus 16 is 116. That does not equal 144, so that would not be a triangle there. Looking at number 6. Find the missing links, show all your work, and leave answers in simplified radical form. So here we have a 45, 90, which means this is also a 45-degree triangle. Don't worry about the shape. Just know that if that's 45, that's 90, what's left is 45. For our formulas here, we know this is like an A and an A and an A root 2, right? Because it's a special triangle. So if that's 13, then x is equal to also equal to 13, and y is equal to 13 root 2. Looking at number 7, again, this is a 45-degree angle here, right? So this becomes my A, and my A root 2, right? Because that's what that should be there. Interesting. So my x value is 3 root 2, no problem there, right? So now to find the y value, what's y going to equal? Well, y is A root 2, right? So let's replace A with a value that I know A is. A is 3 root 2. Root 2 times root 2 is going to become 2. And I still have the 3 on the outside, and 3 times 2 is 6. So y equals 6. And that's my solution for number 7. Number 8. Here we have a 60 and a 30 triangle. When I do 30, 60, 90, the short side is my A. My hypotenuse is my 2a, and my adjacent side over here is going to be my A root 3. So I know that A is 5, which means that for x is going to be 5 root 3, and y is going to be 5 times 2, which is going to be 10. Alright, moving over here, here's 60. So this becomes my A value, this becomes my 2a, and this becomes my A root 3. So noticing here, it gave me my A value, so x is equal to 12, which makes y equal to 2 times 12, which is 24. And that's what I got there. Turn the page, let's look at number 10. Number 10, here we go. Find the measure of angle A to the nearest degree. So here's where A is at there. And we can see we have the opposite and we have a hypotenuse. So with the opposite and hypotenuse, I'm going to look for the sine of a number, of an angle, is equal to 3 over 7. So theta is equal to the inverse sine of 3 over 7. And I have to use a calculator for that one there. I press the second number and do sine, and 3 divided by 7. And that's going to equal 25.37. The nearest degree of 25.37 is just going to be 25. So 25.37, which becomes 25 degrees for number 10. Okay, number 11. We want, again, it's all looking at angle A. So here's angle A. We have the opposite and we have an adjacent. So again, that's going to be a tangent of theta equals our opposite over our adjacent. So theta is equal to the inverse tangent of 4/13. So we do tangent, second degree tangent, and then we do 4 divided by 13, and that gets us 17.1. 17.1, so the nearest degree is going to be 17 degrees for number 11. For this one, here's A, and we don't have an opposite, but we have a hypotenuse and an adjacent. So that's going to be the cosine of theta equals the adjacent over the hypotenuse. And so our theta is equal to the inverse cosine of 5/8. So we do second cosine, we do 5 divided by 8, and we plug that in there, we end up with 51.3. And for the nearest angle measurement, that's going to be simply 51 degrees there. Number 13, find the length of AC rounded to the nearest tenth. So here we have a degree measurement. We're looking for the opposite, and we're given the adjacent. So I'm going to take the tangent of 23 and set it equal to x over my adjacent there. I'll multiply this side by 12 and this by 12 to eliminate that. So 12 times the tangent of 23 is equal to 5.09. So 5.09, the nearest tenth, is going to round that up to 5.1. For this one, we have 84 degrees here, We want to find the length again of AC, so we're looking for the opposite side still. And we have an adjacent, so same idea. This is now the tangent of 84 equals x over 3. So I'll multiply both sides by 3 to make that go away. And then 3 times the tangent of 84 is equal to 28.54, and the closest tenth to that is 28.5. And finally over here, looking for the opposite again, and I have a hypotenuse, so that's going to be the sine of 40 equals x over 71. So I'm going to multiply both sides by 71. So I have 71 times the sine of 40 equals 45.63, and the nearest tenth is 45.6 for that length right there. And that's 15. All right, let's look at number 16. Set up each of the equations without solving and give the letter answers. Determine which of all the following equations are true. All right, so the sine of A. So here's A. Sine is going to be opposite over hypotenuse, so the opposite should be 5. Is that true? That is not true. They did the hypotenuse, so that's not true. The sine of B, again, looking for opposite over hypotenuse, so here's B. Opposite is 12, correct. Hypotenuse is 13, that one's okay. Cosine of A, that's going to be adjacent over hypotenuse, so A adjacent is going to be 12 over 13, that would be wrong. And the cosine of B is going to be the adjacent, which is 5 over the hypotenuse, which is, right, adjacent over hypotenuse, which is going to be 5 over 13, so that one's going to be okay. So we would say, in our case here, B and D seem to be okay. Number 17, which equation could be used to find x in triangle ABC? So we have an angle measurement, we look across, and we have an opposite, and we have an adjacent. So that to me looks like a tangent of 27, right? It looks like a tangent of 27 equals x over 12. We'd multiply both sides by 12 to get the x by itself. So I'm looking for probably that type of equation. Where do I see that at? I see that right here at C, 12 times the tangent of 27. Number 18, which expression we use to find the value of x? Here we have an angle measurement. We're looking for the opposite, and we have a hypotenuse. So when I have opposite and hypotenuse, I'm going to find the sine of 50 equals, and then our opposite, which is x over 3. I'm going to multiply everything by 3, so I'm probably looking for 3 times the sine of 50. And where do I see that at? I see that down here at 3 times the sine of 50, choice D. Okay, moving on to our next page here. So our last page. Number 19. Which of the following equals the sine of A? All right, so the sine of A. Well, in this case here, sine of A is going to be the opposite over the hypotenuse, 4/5, right? So I'm looking for which one of these other values is the same as 4/5. So the sine of C. So C would be the opposite, which is 3 over the hypotenuse 5th. Nope. The cosine of A. And the cosine of A is going to be the adjacent 3 over the hypotenuse, which is 5. So that's not going to work. The cosine of C is going to be the adjacent, which is 4 over the hypotenuse, which is 5. That matches. And the tangent of A, which is the opposite over the adjacent, so 4/3, does not match. So we would say C. Number 20, which of the following equals the sine of A? So here's A. The sine is the opposite over the hypotenuse. So we're looking for the sine of A, which is 3 over 5. So which one is 3 over 5? Let's take a look here. The tangent of A is going to be the opposite over the adjacent. Okay, so looking for one that matches the 3/5 here. So tangent of A. So tangent is going to be the opposite over the adjacent. That's 3/4, doesn't match. The sine of C, that's going to be the opposite over the hypotenuse. That's 4/5, doesn't match. Cosine of C. That's going to be the adjacent over the hypotenuse, which is 3/5. That's a match there. And then we also have cosine of A, which in our case here, we would say cosine of A is, where's A at? Is the adjacent over the hypotenuse 4/5. Okay, so we're going to say that C is the correct answer, and we're good there. Looking down at number 21, identify all equations that are set up correctly to find x. All right, so there's x. So let's see, cosine of 40. If this is an angle measurement, that'd be adjacent over hypotenuse. So x over 35, that is correct. Tangent of 40, opposite, right? Is that our x value? I already know it's not going to work. So nope, not going to work. Cosine of 50. Well, we have to figure out a measurement here. This is 50 because 50 plus 40 is 90. So cosine of 50 is going to be our adjacent. That's our adjacent on this case here. So that's not the x value, not going to work. The sine of 50, that's going to be the opposite over hypotenuse, which matches that. That's going to work there. And for sine of 40, again, that's going to be the adjacent, or sorry, the opposite, sorry, in this case here, opposite from 140. That's not our x value, so it's not going to work there. All right, moving down here. A television screen measures approximately 55.5 inches high, okay, 15.5 inches high, and 19.5 inches wide. A television advertised by giving the approximate length of the diagonal of its screen. How should this television set be advertised? So what is the diagonal of that screen is what we're looking at there. So to find the diagonal here, what we want to take a look at is we're going to take a look at the lengths 15.5 squared plus 19.5 squared and set that equal to x squared. Alright, I do not know what those are, so I'm going to do 15.5 times 15.5, and that equals 240.25 plus 19.5 times 19.5, which equals 380.25. We're going to add that to 240 plus 0.25, which equals 620.50 equals x squared. So now we do the square root of that. So square root of both sides. So what is the square root of 620.5? We're going to clear this and do the square root of 620.5, and we end up with 24.9 equals x. So the price just says 24.9 inch television. Alright, number 23. A tree, there's our tree, casts a shadow that is 22 meters long at a certain time of day. The angle elevation of the sun from the tip of the shadow, so here to here, that angle is 47 degrees. What is the height of the tree? Okay, so we have an opposite and we have an adjacent. So let's use the tangent of 47 is equal to the opposite over the adjacent. Multiply both sides by 22. And so 22 times the tangent of 47, 22 tangent 47 is equal to 23.59. So 23.59 equals x. Rounding that up, we'd say 23.6 meters is what we have for our tree. Number 24, a ladder is 20 feet long leaning inside of the building. Here's our building, here's our ladder, it's 20 feet long, there we go. Okay, if the angle formed between the ladder and the ground is 75 degrees, how far is the bottom of the ladder from the base of the building? So x right there. So we're not looking at the opposite, we're looking at the adjacent and the hypotenuse. So that's going to be the cosine of 75 equals the adjacent over the hypotenuse. We'll multiply both sides by 20, and so we end up with 20 times cosine 75, which equals 5.176. 5.176. Round that up, that becomes basically 5.2 feet is where that's going to be located. And finally, number 25, we have to solve for x, so we're looking for the opposite and the hypotenuse. So that's going to be the sine of 50 equals the opposite over the hypotenuse, which is 200. So we have 200 times the sine of 50. Let me put that in there. 200 sine 50 and we end up with 153.2. 153.2 equals x. And we're done with that, and we're done with this activity. So that's it for now. Good luck in your test, and we'll see you next time.